Okay, we're going to go ahead and get started. First and foremost, thank you on behalf of Stratasys for joining us today. We are excited to be giving you a glimpse of the possibilities in the automotive industry and how Stratasys sees this rolling out with our customers and partners around the globe. Today, speaking with us is Charlie Lee, our Senior Applications Engineer, based in our Stratasys Experience Center in Shanghai. So Charlie, thank you for coming and being with us and sharing your knowledge today. Charlie, if you could go to the next slide. Okay, before I tell you a little bit about Stratasys, I promise to only keep this very short, maybe 2 minutes. I just wanted to make sure that everyone is aware of a few resources that is in the user interface of GoToWebinar. First and foremost, if you have a question, please feel free to type that into the questions tab or the chat tab. We intend on reading the questions off at the end of our webinar when we get to our questions and answer time. If we cannot get to every question, then we will actually address the question with an email to you directly. And it'll either be me or it'll be Charlie who answers the question on behalf of Stratasys. Also, I'd like to point you to the handouts section. There are 3 handouts that are available. First off, we're going to be covering off 2 major technologies. It's not the only 2 we will cover, but we're covering FDM and PolyJet. And just for your convenience, we've added a brochure in the handouts section of this user interface. Last but not least, there is a copy of the full presentation in PDF form that you can also download, and we encourage you to do that. So just a few minutes about Stratasys. So if you don't know Stratasys, we are over 30 years old. We're actually 31 this year. We have over 140,000 installations of our 3D printers around the world. This does not include our MakerBot range, where we would be probably well over 1 million installations worldwide. We are publicly traded on the stock exchange, so you're able to set up Google alerts about Stratasys, and that way you get all of the information of new products and new releases that we bring to market. Charlie, if you could go to the next slide. So Stratasys, we are headquartered in Eden Prairie, Minnesota, as well as in Israel. And we actually have 14 offices around the world. And I would actually say 14 rather than 13, because we now have an office in Melbourne, Australia, which is where I'm coming from. We also have over 155 resellers in our network. We actually have 5 resellers around Australia, New Zealand, over 2,100 employees inside the Stratasys inside the Stratasys company. I want to point this out to end my part, but everybody knows, or what we are primarily known for is our FDM and PolyJet technologies. But what you may not know, or you may not have heard yet, is that we've actually just over the last few months brought SLA, selective absorption fusion, and DLP into our range of technologies through acquisition. So I encourage you to go on to stratasys.com and have a full look. This actually brings our range widens our range quite significantly. And for the most part, unless you wanted to talk about metal, we have a technology that is available in the industry. So I encourage you to have a look on stratasys.com and understand more about our full product range now, which has significantly increased over the last few months through acquisition. You could go to the next slide. So again, I would like to just very quickly introduce Charlie Lee, our Senior Applications Engineer. This is where I'll be going on mute and be turning it over to Charlie. Again, Charlie is located in our Shanghai Experience Center. So Charlie, thank you for joining us, and I'll turn it over to you.
Thank you, Ben. So hello, everyone. My name is Charlie. Thanks for Ben's introduction of our company's background. Today, I'm going to share with you some thoughts, some ideas about the possible future of automotive production in the future. So let's say the contents today. So I'm going to give you a quick go through about the evolution of auto industry, some possible future of automotive production ideas, and the most important is how Stratasys solutions to help solve those possible challenges and give us a bridge to link to the future. And also we're going to have a 5 minutes of a question and answer session. So you're welcome to bring your questions in the chat, and we will help to answer that. So everyone must know this man, Henry Ford. He's the guy who invented the automotive production line, which is still being used today. And for, let's say, for over 100 years, there's no big change in the manufacturing workflow. I mean, workflow is about from stamping to general assembly of our automotive. So there's no big changes. But every process engineers or automotive engineers, they are facing the same challenges. For example, today's car is one size fits for all. But how can we improve the customization of every car and make that car to meet everyone's needs? And also, how can we improve the automation rate to reduce the labor involved in the production? And the most important thing is, how can we make the workflow lean and more efficient and reduce the cost, reduce the waste? That's the problems everyone is facing today. And I think that the answer is implying there. The answer is implement new manufacturing methods such as additive manufacturing, injection molding. We can help to solve those challenges. By implementing design innovations, we can make sure that some product which cannot be realized using traditional manufacturing method can be realized now in the future. By using a highly integrated design of your product, you can short your BOM list and makes your production lean and more efficient. The on-demand production is also a thing that we can solve by using additive manufacturing. A lot of personalized requirements can be implemented on your part using additive manufacturing, which is by meaning of on-demand production. So let's say how design innovations helps to solve the current challenges. As we can see here, using this is a car. For example, here is a car, and this structure can never be realized using the traditional manufacturing method. And by using a Stratasys soluble support, you can unleash your design. It is able to help you to create complex, intricate designs without any problems. Also, you can using additive manufacturing to reduce the weight. So make the lower the weight of your car, it means more mileage you can get. Also, generative design is a very popular topic we're keep talking today. So using with that topology optimization, we know where we can reduce the weight but not losing the strength of your car. For example, this is a pioneer of the new autonomous mobility, Metro Snap, is featuring a new swapping system, which, unlike traditional ways of manufacturing a car, they have a separate body and a chassis. So over 30 interiors and exterior components of this car were printed by Stratasys Fortus 450 machine using ASA UV stable material. And also some structure parts were printed with nylon 12 carbon fiber, which is also a well-known material which has the highest stiffness to weight ratio that helps to build this car. By also you can not only in the car itself but also the manufacturing tooling side, we can using the generative design and try to help reduce the weight of fixtures. And you can see here by using generative design, we are able to reduce the total weight of this fixture from 68 kilograms to 12 kilograms, and also reducing the total lead time. The ROI of this fixture can be achieved within 12 months, which is a significant number for every customer in the tooling area. Topology optimization helps us not only reduce the weight, but also keeping the same strength. As you can see here, this is the battery housing for self-balancing scooter. We can reduce almost 85% of lead time, and using the tough nylon 6 material, we're able to make sure the overall strength or the of this battery housing is the same as traditional design as designed by traditional ways. So this is a very good example to showcase the design innovations help to solve the problems in traditional manufacturing ways. Another thing I was thinking is highly integrated components. As you can see here, with this this is a safety buckle bracket, and traditionally this part was made with 8 components, but with the innovative design and highly integrated design, we are able to cut down 8 components into 1 part, and which means it can save you 40% of weight, but in the meantime even make this part more stronger. So this is a very good example to showcase highly integrated components help to solve the problem. Also in the tooling area, this is the window alignment tool, which was printed using nylon 12 carbon fiber material. And you can see here in this left corner, the traditional way of manufacturing this window alignment tool was using aluminum alloy, so it weighs a lot. But we can help to print this part with only carbon fiber reinforced frame, which can consolidate every metal components into one. That's very good for the weight reduction in this case, and help to improve the ergonomics of operators as well. In the GrabCAD, this is the GrabCAD software is a software developed by Stratasys, and we can apply multi-bodies, and we can apply advanced FDM's feature in this software. You can print multi-bodies in this software by adjusting the density of different components. In this way, you are able to reduce the total weight, but not losing the strength. That's very powerful tools for your design. Also, we are team up with a topology software team to make sure we can build the fixture, for example, in the future more easily and cost efficient. For example, here is the anti-rotation fixture. So you can see here, by applying fractal infill, we can reduce the resources of printing this part by maintaining the same functionality. On-demand production is very popular topic we are keep talking today. For the automotives, not only in the automotives, but everything else that relates to everyone. So we want to make sure the supply chain is more flexible. It can give your part on demand. Siemens is a pioneer in this area. They actually developed this website that can have all their spare parts installed in the cloud. So if there's a need of printing a spare parts, the customer could place this order on this website. So the digital warehouse will get the orders and print that part on demand. So which significantly reduce the warehouse which helps them to significantly reduce the warehouse limitation, the warehouse. Here's a retrofitting example that, for example, this is a USB charger that was used on the Siemens Mobility, and also the customer could place the order directly on their website, so they can have these parts just when they want. And the Siemens group, they don't need to store hundreds or thousands of these parts in their warehouse. Also on the production line, you can see here fixtures and also the toolings is the same thing as we talked before. It's a very the fixtures is used on each station, and that is very unique. That's not for mass production. So the customer also needs to have this kind of toolings to be produced on demand. For example, here is a hemming tool developed in Chevrolet, and they are able to print this part with ASA material on a photos machine. As the same concept we mentioned before, it helps the customer to reduce the weight from 34 kilograms to 14 kilograms. So it can help to improve the work efficiency on the production line. This is a checking gauge that is also printed on demand. Not this kind of fixtures were not required every day on every line, but when there's a need, the customer could able to draw the CAD data in their software and produce in an additive manufacturing way. So it helps our customer to reduce the spare parts, reduce the place in the warehouse. And talking about the additive manufacturing ways, FDMs, when we talk about FDM systems, the thing we come in mind is how reliable these systems are. When we using a Stratasys FDM system, we are always getting a reliable process, a controlled process of your production. It is a very suitable manufacturing method for industrial applications I listed here: prototyping, jigs and fixture making, and also the production. But bear in mind, FDM is the most suitable additive manufacturing ways for low volume production, which is suitable for production volume below 1,000. Of course, we have different other technologies to complement this one. I will talk about it later. The PolyJet is another very good. It's another manufacturing method we are proud to own in Stratasys. It is a very good at full color printing, but probably people have thoughts about how can this technology be used on a end use part. But But actually, we have an answer for that. We are team up with Mini, and we help Mini to supply these customized parts to be installed on their side scuttle. So this customized parts was printed purely with 3D with PolyJet technology, and the customer are able to get their personalized pattern and words in the and the text in this side scuttle. And in Stratasys Shanghai office, we help to produce these parts. We are able to produce 1,500 sets in only 8 months, and that is the first use case of full color 3D printed end-use part for a car. We have tested this part many times to make sure that it can meet the it can meet the requirements that in the automotive industry. H350 3D printer is a new product we brought in this year, and it is a suitable technology for a mass production. This technology helps us to produce a production grade parts, and we have with this technology we are able to control your manufacturing process and control your cost. It is the one of the most cost-effective manufacturing ways for customized parts. H350 is actually using a SAF technology we talked about. It is using an industrial grade printer head, which gives you a best cost effective for making your parts. It is using an industrial printing heads, which makes sure you don't need to worry about consumables during the day-to-day production, and you don't need to worry about the reliability of this machine. It can make sure that it works 24 times 7 hours continuously, and no one worries about this. No one worries about the stop. And also it's using a powder bed fusion technology with nylon 11 material, which is widely accepted in the industrial in the automotive industry. So if we are comparing SAF and FDM, they are actually two complementary technologies. Especially SAF technology is aimed at a production volume of few 100,000 parts per year, and you are able to get your parts on the next day, and it is very good with it is very at the beginning we are going to start with only one material, which is nylon 11, but this material is very eco-friendly and widely accepted in the automotive industry. So also this PA11 material has a high ductility, high impact. So that's why the automotive OEMs accept this material, not PA12. That's because it has very good impact resistance. And also bear in mind, this material is 100% bio-based from sustainable castor oil, which is also make sure this material is not creating any pollution to our environment. That's very important in today's topic. Origin One is the last new product we are going to introduce in 2021, and also this technology is suitable for a functional end-use parts production. Same as SAF, it can give you a very good throughput as well as injection molded part quality. So some people might have some doubts about the printing quality, especially the surface finish of 3D printed parts. But with Origin One, you don't need to worry about it. You can keep all your details on your end product with some very fine details, because it is made with this manufacturing, your part is made with a DLP process. So every fine details will be kept on your final product. Also, we are working together with the leading material suppliers, for example, like Bosch, DSM, and Henkel, to develop new materials that can be used on the end product. So in the future, there are a lot of possibilities to enable this technology on making end-use part. High throughput is also one thing we need to mention again and again for this technology. So with this technology, you are able to get your parts in a very large quantity and at compelling prices. So here we have compared these parts between different technology we own in Stratasys. So you can see here both staff and origin, this P3 technology are able to make few hundred of thousands parts per year, which is suitable for mass production, while we are maintaining the very cost-effective price per part. And here you can see we also, at the launch of this new product, we are able to offer a wide range of high performance materials. Some materials are able to withstand the high temperature up to 300 degrees Celsius. And also some materials we are able to have a high impact resistance. And also we are able to make sure this material can meet various applications in the automotive industry. For example, we also having elastomer material on this platform. So some rubber material or sealing materials usage in applications in the car can be covered by this technology. As you can see here, some detailed pictures about the printed parts. We can see here we are able to maintain all the fine details and on your product, so you don't need to worry about 3D printing that has a bad surface finish. With Origin One, we are able to keep surface roughness as low as 2 microns, and we are able to keep these fine details to 0.1 millimeters. So that is injection molding quality. So if once you get this your product print by Origin One, you will be surprised by the quality. It's not like other 3D printing technology. It is a very advanced technology that is aiming at a future mass production. So let's wrap it up. The key attributes of Origin One: it can gives you the production grade part quality. It gives you a highest throughput comparing to other AM technologies. It is very easy to handle, and the workflow is simple to very straightforward to use. No one need to get a lot of training to get use of this new technology. Also, the post-processing is not that labor involved. It's very fast, only takes 15 minutes of UV post-cure. So by combining every technology we are talking today, we are able to help to solve the challenges we're facing today. How to improve the customization of the automotive for everyone. How to improve the automation rate on the production line. Also, the on-demand production. So we can make sure that using Stratasys AM solutions, we can help to solve those challenges. And in the future, we believe This by using AM technology, especially the solution provided by Stratasys, we are able to help those challenges. Design innovation, highly integrated, on-demand production are the directions we are going to work in the future. So thank you for today's webinar. And if you have any questions, I'm very happy to answer together with Ben. So Ben, you might